Hey there, welcome to this learning series on large language model LLM. This is a very exciting time to be in this field. We have recently seen a small Chinese company called DeepSeek AI with its R1 model has created waves in this field. In this video of introduction to this series, I'll start with explaining what are the different types of artificial intelligence. Then I'll move to generative AI and share what are the different subfields of generative AI with their applications. After that, we'll start focusing on LLM. We'll talk about what are the use cases of LLM and how they are being used in our everyday lives. Then I'll explain what is the meaning of the word large in this context of large language model and why it really matters. I'm particularly excited to introduce you the 3-track learning structure that I have created. We'll start with track 1, which is on foundation model and how to train a foundation model from scratch. I'll explain at a very high level how this language model works and how they are trained. By the end of this video, we will have a clear understanding what are the prerequisites to follow this series and how to get most out of it. I am having an incredible time putting this content together, and I'm sure you will also find this content very exciting. If you are excited about this journey, don't forget to subscribe this channel and give a thumbs up to this video. Are you ready? Let's dive in. AI has two main types, predictive AI and generative AI. Since the 1950s, AI has mostly been about analyzing data and making predictions, which is why it's called predictive AI, or sometimes also referred as discriminative AI. But AI has come a long way. Now, with deep learning, we have generative AI, which doesn't just predict things, rather, it creates completely new content like text, images, music, even code, and whatnot. This shift is changing everything from automation to creative industries, making AI more powerful and exciting every day. Let's explore the difference between generative AI and predictive AI with a quick example. In generative AI, I can give a prompt like create a funny joke about generative AI, and I will expect to get a brand new response. For instance, when I asked ChatGPT, I got this response. Why did the generative AI break up with its neural network? Because it kept completing its sentences but never truly understood its feelings. Interesting. Same thing I did with DeepSeek AI, and here it is. Why did the generative AI go to therapy? Because it had too many deep-seated issues and couldn't stop generating random thoughts. Amazing. Now, compare this with predictive AI. Here the goal is different. I asked the model to detect the language of 3 different texts. And yes, I took the same text that ChatGPT generated. So in the first case, model said it's English. Next one, it was Bengali. And it's correct. In Bengali, this sentence is কারণ সে সব সময় তার বাক্য সম্পূর্ণ করত, কিন্তু তার অনুভূতিগুলো কখনো সত্যি বুঝতে পারত না. Amazing. And the third one is Hindi. In short, generative AI creates new content while predictive AI makes prediction based on given data. Now let's dive into another example from the world of images. In generative AI, if I ask the model to generate a face, I'll get unique new faces each time. It could be a cat, it could be a dog, or it could be human face. But at the same time, I can also do a conditional generative model. Here I can say, give me a human face. So this time, model will generate brand new human faces. Now, in case of predictive AI, the approach changes. If I ask, is this a human face? The model checks the discriminative boundary, and after checking, it will say, yes, this first image is human face. Now another image, and again it will check, and it will say, no, this is not a human face. So that's how generative AI and predictive AI differs. Now, in the world of generative AI, there are several types of model that each serve unique purpose. Let's take a look at some of the prominent ones. Large language model, LLM. So what they do? These models generate text-based content, which could be used in chatbots, content writing, even code generation. Examples: GPT-4, Gemini, Llama, and many more will be covering in details in this series. Then there is text to image. What it does? It creates new image based on text prompt. I'm sure you might have heard the name of Stable Diffusion, Midjourney, DALL-E, Flux. They're generating realistic image which can be used for art creation or even in advertising. Then we have text to video. Similarly, based on text prompt, it creates video. We have text to speech model. It can generate realistic voice based on text. In fact, it can even mimic the voice of some celebrity or someone. These models can be used in audiobooks, virtual assistant, dubbing. Some of the examples are 11 Labs, Wally, Google WaveNet. Then we have image to image model, where from an image, model can generate new image or change some of the content in the image. We have speech to speech model, where speech from one voice can be transferred or changed to another voice, keeping tone and emotion. Code generation model. These models are used to generate code. Tools like GitHub Copilot, AlphaCode, they are revolutionizing the way developers write their code. Music generation model. As name suggests, these models can generate music. Text to game model. These models can generate game based on text prompt. OpenAI's Voyager and Unity AI tools have already brought some game. We have also something called multimodal models, which combine tasks from different domains: text, image, and voice generation, just like an all-rounder in a game of cricket. In this series, our focus will be on large language model. Now let's explore a little bit about large language model, how and why they are making waves in various sectors. LLM falls under the larger category of AI called NLP, which is natural language processing. Now, when it comes to key things that these model can do, I will list a few here. These models can generate human-like text. So this can be used for article writing, storytelling, blog creation. It's good at summarization. So it can condense lengthy text into concise summaries that can be used in news, research paper, code generation, translation. In translation, it can translate text between different languages. There are widespread usage of it, like in multilingual support, localization, question answering, QA. They provide accurate answer to queries, search engine, customer support. All these are using LLM model for this purpose. Creative writing. LLM creates poems, lyrics, scripts, text completion and autocorrect. They predict and complete sentences. Applications like email drafting, writing assistants, all these are possible. Sentiment analysis. LLMs analyze emotions and opinion in text. Nowadays, LLM is heavily used for brand monitoring, social media analysis. These models are even becoming very good at reasoning, at logic. They perform logical deductions and reasoning, and it has found its use in legal AI, decision making, and in many more areas. So, this is just a small sample of use cases. Those are increasing every day. Every now and then, we are seeing some amazing usage of this large language model. So, LLMs are more than just language generators. They're transforming industries with their wide array of capabilities. Now, in the world of large language model, what is the meaning of this large? The large is a bit relative and it's constantly changing. What once seemed to be huge now appear tiny. As we build more and more powerful models, today's top models will likely become smaller compared to next generation new models and maybe outdated. So, what makes these models large? There are three key factors. First is training data size. The sheer volume of data used for training these models that makes this model to be called as large. In some of the state of the art models, almost entire internet data is being used. The data is collected from web crawls, books, academic papers, scientific papers, code repositories, multilingual data sets, Stack Exchange, GitHub, and many, many more places like private repositories, libraries. One of the reason that is driving or why you are calling them large is because of this sheer volume of data that is being used for training this model. Other important things are parameters and the GPU. If you can see here, these models are trained with billions of parameters, with some already hitting almost trillion mark. And I'm sure in a few years, most of the models will be in trillion or even more. So if you can see, GPT-1 started with 117 million. By GPT-3, it was 175 billion. GPT-4, OpenAI didn't publish, but it is rumored to be around 1 trillion. The latest kid in the block, DeepSeek, has 671 billion parameters. The other thing is the GPU or graphical processing units. This can be calculated or considered in two ways, either the number of GPUs or the total computation hours using GPUs. Some are not mentioning GPUs anymore. All the proprietary models or prominent models nowadays don't publish number of GPU they have used, but you can guess from the trend It started with 8 in GPT-1, and by the time GPT-2, it was 32 TPU, and Palm used around 6,000 TPU. So all these models definitely runs into thousands of GPUs, and it usually takes few months to train these large models. As technology evolves, the goalposts keep shifting, and what's considered large today might look very different in the near future. But overall, these large models are large due to these three facts: data, parameter, and processor or GPUs in use. In this LLM learning series, we'll be covering three key tracks. Track 1 will be based on building LLM from first principles. Track 2, using existing LLM to build applications. Track 3, fine-tuning existing LLMs. I'll be focusing mainly on track 1 and track 3. There will be some overlap between all these three, as there is no clear demarcation, but I'll try to keep things organized in these three categories. Now, a quick note: this field is evolving extremely fast. What's cutting edge today might be outdated tomorrow. Transformers are the foundation of most of the LLMs right now, but depending on when you are watching this video, things might have changed. I'll do my best to keep updating this series as new techniques emerge and become widely adopted. Now, as part of track 1, build LLM from first principles, it means we'll be building an LLM from grounds up, completely from scratch. These models are often called foundation model or base model. Think of it like a general practitioner or GP. A GP starts with a broad medical education, learning the basics of medicine and surgery. Once they complete their basic training, they specialize in a field of like eyes, heart, or brain. That's how we get ophthalmologists, cardiologists, neurologists, and many other experts in the field of medicine. Similarly, once a foundation model is trained, it can be further refined or fine-tuned with domain-specific or task-specific data to specialize in a particular function. That's how we get generative chatbots like ChatGPT, which is fine-tuned from GPT-3 or GPT-4. We also have Microsoft Copilot for productivity, Bloomberg GPT for the financial industry. Each of these is built on a strong foundation but customized for a specific purpose. Now, this course will be a blend of concept, theory, and best practices. We will be using Python for coding. We'll be using well-known libraries like PyTorch, Hugging Face, etc. I'll cover best practices and different approaches adopted by leading model creators. In the track 1, first we'll start with data pre-processing. We'll go very deep in some of these topics. We'll start with data acquisition. But again, this track 1 is focused on beginner-friendly, bottoms-up, large language model creation. Our intention would be to build a toy large language model using a small dataset. It's a PC-friendly. Even if you don't have GPU in your personal computer or laptop, you should be able to use the code to explore and understand the concepts. So we'll be covering tokenization, various tokenization methods. We'll learn about token embeddings, positional embeddings, and many other concepts like context size, different techniques involved in pre-processing tokens, vocabulary size, like this, many concepts and codes associated with it. Next, we'll put a lot of focus on attention mechanism and transformer architecture and different variations of transformer architecture. We'll also refer some of the state of the art architecture that's being used by some of the models. We'll look into model size, layers, and many, many more things as part of model architecture. Next, we'll dive into training and evaluation. We'll see how to set hyperparameters, how to create training loop, what are the evaluation and checkpoints, logging, observability, all this need to be set for proper training and maintaining the model. We'll use different evaluation metrics. We'll also learn about what are the metrics. We'll talk about business metrics. We'll learn about performance benchmarking. There are many benchmarks available which top models are currently using. But in our toy example, we'll just scratch the surface. But conceptually, we'll look into the various benchmarking that is available. Lastly, we'll look into post-training processing. We'll see what are the advanced fine-tuning techniques like supervised fine-tuning, RLHF, what are the alignment and safety training that would be required after basic training is completed. Then what are the guardrails need to be built for avoiding toxicity, biased, and different other challenges that comes with language models. We'll learn all of them. Some of them will be very conceptual because we may not get a chance to implement them in our toy dataset or toy example. But you will have enough information to understand how it works. Now, how LLM works? At very high level, model learns by predicting the next word in a sequence, like completing a sentence. So for example, I would like to generate a sentence. My first word is I. So model will generate next word, which could be want. Next time, model will generate two. So when it generates two, it's using previous I1 to decide what would be the next word. Next step, we'll get learn. Similarly, after that about, and maybe at last we'll get LLM. And that's how the entire sentence will be generated by LLM. And as you can see, every time it's using previous words to decide what comes next. And we'll later see this is based on some probability. And based on probability, it will decide what next word comes. Thus, these models are called autoregressive, meaning they generate text one word at a time, always relying on the previous words. Now, how LLM is trained? Suppose I have a training text. I love coding to create LLM model. There won't be any human explicit leveling to tell the model. Rather, at the time of pre-processing, the model itself will create its target words or data based on previous words or some technique called masking. The first way is to predict next word. Suppose in this case, I give the model I love coding to create LLM and then blank. What model will do, based on this training data, it will see, okay, this blank page is model. And that's how it will use this in training process. This is the approach used in GPT-based model training. This technique is called causal language modeling, CLM. Another way could be to use mask for the words. Like I can create a masking in between. Say I love mask to create LLM model. In this case, masked word would be coding. Similarly, another masking could be create for this masked word. So you can see model is trained based on this sentence itself. It's a training data. The model is using this to deduce this. So this type of training is called self-supervised learning. Now, these masking patterns that we have shown here is a technique, predicting technique, which is called masked language modeling, MLM. This technique is used in BERT. We'll learn in detail about how this self-supervised learning work, how we set the data, how we do this setting in pre-processing time. Now, before we end this video, I think it is good to know what are the prerequisites for this learning series. A basic understanding of machine learning and deep learning will help, especially when we dive into key concepts and technical terms, but it's not mandatory. If you want to follow along with the coding implementations, some knowledge of Python is required. But don't worry, if coding isn't your thing, you can still grasp most of the concepts, as I will explain everything in simple English. The most important thing that is needed for this series is a lot of curiosity and enthusiasm. Some parts might get a bit dense, and we'll use math and statistics to break down certain ideas. But even without strong math background, I would say you will be able to grasp more than 90% content of this series. I'll also share many reference materials like research paper, books, blogs, AI community portals, YouTube videos. There is already a lot of good content out there from many experts and masters. And I strongly feel, rather than trying to reinvent the wheel, I'll guide you to the best source when needed. All right, let's get started. Next, we'll have tokenization.